EDTC6325 Section 1, Group 1 presents how using Second Life can be useful to educating our students of all grade levels in and out of the classroom. Ladies and gentlemen, under the direction of Team 3, consisting of 5 members, we'll be taking you on a Second Life virtual tour as part of our EDTC 6325 Section 1 course in the Masters of Educational Technology of the University of Texas at Brownsville for our Summer Session 1 group project, with our destination being the International Spaceflight Museum. Albert Alvarez will start our tour introducing us to its 2 most pleasant features before handing it over to Jose San Miguel, who will take us on a tour of a room full of mysterious stories, which we call the planetarium. Adam Rethlake will continue the fun with pointing out free tour guides in the Second Life site and activities to do while in the museum. Reina Rangel and myself, Roberto Garcia, will close the tour with our points of interest with physics astronomy at the science school. We hope you enjoy. Buckle up and prepare for blast off.
For our Second Life field trip, we have chosen one of the founding destinations of Second Life, actually. The International Spaceflight Museum is one of the most interesting exhibits in Second Life. It was founded in 2005 by people who were indirectly involved with some of the special projects at NASA. One of them was by the name of Kat Lemure, and I'm sure that's her Second Life call sign. But her father worked as an engineer for Cape Canaveral in the 1980s, and she helped found the museum and helped design its constructs. She was also a Second Life designer who helped create the model of the International Space Station found at our next destination. So I think for obvious reasons, the science, math, history, and storytelling of this museum is a great way to engage students in learning. Here at the International Space Station, there is so much to study and admire, as you can see. We would be able to talk about the Cold War and how the space shuttles, like the one docked here in the 1980s, were a way for the United States to continue to control space and space flight. But the construction of the station is an example of how American, Russian, and Japanese governments set aside their differences and they work together. I want you to rotate a little bit and look at all the different rockets that have been designed here. Now, there's something interesting about these rockets. If you take a look at all these rockets, most of them were made by Second Life user Hallery Pascal. And what's really neat about each of these rockets is that she designed these from 2D illustrations and pictures, essentially from scratch, by using proportions from the photos, because the specs are top secret and are not available to the general public. So every single little bit of history of space and space flight that these rockets exemplify, they're top secret. They're, like I said, their specs were not available to us, and they were able to reconstruct them. And every facet of space flight is represented on this nice little deck here. Even the two the monkeys that they were using, the chimpanzees, to be able to launch into space and see if it was possible for humans to actually do any kind of space traveling, they're also honored in some of these rockets that you see here. So it's another potential to be able to go one step further. And for me, it just falls right in line with the STEM kids, and to be able to teach them, about technology and science and how the mathematics and engineering, they just blend together, and they work hand in hand when it comes to a museum that represents all of our disciplines in the STEM on the STEM team.
I chose to talk about this place because I'm a big fanatic of the constellations, and especially the stories behind them. The constellations, they don't only tell us stories, but they help us in a navigation tool and for identifying our four seasons. I'm very amazed with the stars can tell you. When I was on the way in a ship, I used the stars to navigate. I was not driving the ship, but I was able to actually know which direction we were heading to. My main point of direction was North Star, or Polaris. And there's a reason why this star is very important when navigating. The North Star does not set, and it's always visible, at least in the northern hemisphere. I may not know the exact scientific reason why the North Star was created at the northernmost point of the hemisphere. But in Greek mythology, it explains that there was a young woman named Callisto. She was a hunter. And one day, when she was hunting in the forest, she grew tired and lay down to rest. And Zeus, the god of the sky, saw her beauty and fell in love with her. Eventually, Zeus' wife found out about Zeus' affair, and she became very mad. And she later found out that Callisto had given birth to a child. So she suspected that it was Zeus, the father. And in order to punish Callisto, she turned her into a bear. Callisto's son was named Arcas, and he was adopted by another family, raised to be a hunter. One day, Callisto saw her son in the forest, and she was so happy to see him that she quickly ran towards him. And Arcas, her son, didn't know he was his mother, so he thought he was being attacked by a bear. And so he shot her with an arrow. He tried to kill her. Zeus was very upset that all this was created by his wife, that he turned Arcas into a bear as well, and grabbed both of them by the tail and just swung them up in the sky. That way they can both live peacefully in the stars.
There are many little games and educational activities here at the Spaceflight Museum. You can take a riding tour. Click on it, you'll really slow everything down. And of course, then you also have our famous red carpet. It's a great tour. It takes you all the way around. Tells you just about everything that Albert said at the beginning of the tour. There's also some really neat little quiz stations around that you can find, and they'll allow you to teleport to another quiz station or to another attraction. And if you follow me over here to the left, or here to this big rocket arm, this is actually an interactive space shuttle robot arm. And also to the other side, if y'all look over here to where the rockets are, where you have the International Space Flight Museum and everything, you have the pre-check flight. You can actually go through the pre-check flight list, and you can type in the Control H and enter into a capsule, and it'll actually blast off and go out into outer space. You can sit there and you can look at all the planets and everything. It's really a pretty cool little trip. It takes a long time, but it's a lot of fun. There's a lot of little things that you can, if you're studying space.
In this exhibit, how do astronomers know what they know? Well, this exhibit illustrates some of the methods that astronomers use to find out about the celestial objects they observe. For example, the telescope. Now, there are many different types of telescopes that astronomers use. There is the reflector telescope and the refractor telescopes. There is a difference between them. The reflector telescope uses two mirrors instead of two lenses. The first reflecting telescope was built by Sir Isaac Newton in 1668. He built this reflecting telescope as a proof for his theory that white light is composed of a spectrum of colors. Now, the mirror in this type of telescope is used to bounce the light back towards the eyepiece. It gathers and it reflects light with mirrors. The refractor telescope is a type of optical telescope. Its purpose is to gather the light from a distant object. For example, a star. It bends into a point of focus. Now, basically, these telescopes use different methods to boost light from the objects in the sky. Now, like I mentioned, there's several types of telescopes. If we continue, there's the radio telescope. Now, the radio telescope is a radio antenna that is used in radio astronomy. Other types of telescopes receive light, but this one sees radio waves that are emitted by radio sources. By using a radio telescope, astronomers can examine the power, the frequency, and the timing from celestial objects. Now, used in the field of astronomy is interferometry. Now, interferometers are used to measure and analyze light and to check for irregularities of the surface. It is also used in radio astronomy. Another method that astronomers use are the adaptive optics. Now, the adaptive optics is a technique used in the field of astronomy that it compensates for distortion caused in astronomical images by the effects of foreseeing or atmospheric turbulence. Now, finally, we have our unhappy astronomer. His view of the heavenly bodies is tortured by moisture and turbulence in the atmosphere, diminished by light pollution, or completely killed by clouds and precipitation.
As we arrive here at the science school, I like to call it the Trail of Honor Science Fair. What I'm going to show you as you follow me is the electromagnetic spectrum, which is the range of all possible frequencies of electromagnetic radiation. This is all physics, which is great for students in middle school and above, possibly 5th grade if you like to count a GT classroom to keep age and level appropriate. Getting back, electromagnetic radiation is energy that travels and spreads out as it goes. For example, like the visible light that comes from your lamp at your house, or even the radio waves that come from the radio station. Those are 2 different types of electromagnetic radiation. Other types can include microwaves, infrared light, ultraviolet light, X-rays, and gamma rays. If you put all the types together, you combine wavelengths will create a rainbow of colors. The process can be pictured as a beam of light going through a window with 2 parallel surfaces. It retracts twice, but it comes out of the same angle as it enters. Within that retraction, the light beam will split, which is called a chromatic aberration, which is a rainbow that you all see right here on the poster. What I like to say is when I did my undergrad, I took Dr. Diaz's class for astronomy at UTB, and during our lab in groups, we each created a rainbow using the petri dishes, telescopes, cutter lenses, beakers with water, and the computer. The math that we applied here was advanced math topics and pre-calculus. So that's pretty cool. I guess if you'd like to say it would be for seniors in high school or possibly at college level, of course. As you follow me a little bit farther, I'm going to be talking to you about the inverse square law. It basically means that the size of something so far away can seem so close as we look at the sun and the stars for a proper example. What I like to compare the way the squares are formed is you can see a 1 square to a 4 and then to a 9 on the red right there coming out of the example of a sun. Like the way of a birth of a cell. Like, for example, block 1, I would say a cell is resting but active, getting ready to divide. The blocks of 4, I would say the chromosomes double and line up in a square in the middle. The blocks of 9, they start to pull very far apart. And then basically 2 new daughter cells, basically it's twice its size or possibly even larger, seeing something. It may seem odd, but the song is from, I remember in 6th grade. It helps me remember the process of squares for the inverse square law.